Hello, everyone. Welcome back to another Out of Spec Reviews video. If you have a keen eye, you might be able to tell that no, I am not Kyle Connor. I am Francie. I run the Out of Spec podcast. And today I'm going to take you on a tour of Kempower's North American manufacturing facility in Durham, North Carolina. I was able to run over there this past week and take a look at what they're going to be doing. They're going to be producing EV chargers for their customers in North America. That is Canada and the United States. And it's going to be hopefully really great. Kyle has used this hardware over in Europe, where Kempower has a much stronger footprint. They are a Finnish company originally, and he really likes it. They've sponsored Out of Spec. We've reviewed their hardware and their charging services, and we have some hopes for North America, but we're really going to have to see what happens. They see it as a market to come into, especially with all of the funding. And now they have their own kind of Kempower startup starting in Durham, North Carolina for North America. So I got a tour of how they will be producing and manufacturing these chargers, not the Megawatt Charger that they have, because there's not regulation to need to build that on North American soil in the US yet. But you'll see the team that I spoke to, who all seem pretty passionate about what they're doing and definitely experts in what they're doing as well. And just get to go through all of the steps of there's like 7 or so different stops that I made throughout the facility for this grand opening. It was the day before. We also had a Q&A with the leadership team, the CEO, the CTO, the COO, the leader of business development, and got to ask them as media a bunch of questions about what they are going to get up to in North America. That is on the Out of Spec podcast channel, where you can catch me talking to you like every day if you want. So definitely go check that out. But here is the tour, and this happened the day before the big grand opening event with all of the public and the global dignitaries, as you can see here, where Kempower opened up their North American doors to business. All right, let's take the tour.
This video is brought to you by StarCharge, the largest EV charging manufacturer in the world. They are also a provider of residential and commercial battery storage with microgrid solutions. Our sponsor for today's video, Amber, offers a modern extended warranty for your Tesla's battery and more without the burden of long-term contracts or upfront payments. Check out the link in the description below to browse their plan options and get started with a free over-the-air diagnostic check of your electric car. We are speaking with, can you introduce yourself and your role with Kempower?
My name is Nick Henson. I'm one of the production supervisors here, and basically I'm sharing a little bit about the production process for our power units and our charging satellites. So just want to start off with the power units. Basically, we use a modular design with our power units, where this is extremely beneficial to the customers buying our systems. It makes it so that they can pretty much customize it to exactly what they're looking for. It allows us to basically build our power cabinets in a way that we can provide exactly the power sources that the customer is looking for. So it's very easy for us to build 1, 2, or 3 door cabinets that meet all the power requirements that the customer is looking for. And on the power units, the way we manufacture them here is they are manufactured on an assembly line, where basically we start at that end, they work this way down the line. Throughout the process, there's different things that we check that we consider to be critical to quality. There's also functional tests that are performed as it makes its way down the line. But basically we're checking critical quality, functional testing, and by the time it hits the end, it heads off into our shipping and packing area, built to all the quality standards that we have here at Kempower. As we make our way a little bit further down, the charging satellites are down at the other end of the factory, and with those, basically the charging satellites, they offer a variety of options on them. There are 200 amp, 300 amp cables, variety of connectors. Primarily what we're doing right now out of this facility is the CCS1. We will be manufacturing NACs very soon. And with the charging satellites and the power units, both of them come where you can customize them to either have Kempower branding, unbranded, or customer-specific branding on them. We also, with the satellites, instead of producing them in an assembly line, we produce them in like a cell manufacturing type setup. So basically we build the individual sub-assemblies for the satellite and then bring them all together in final assembly, test them, confirm that they meet all of our quality standards, and then they get packed, sent out to the customer.
Great.
Couple of things to touch on. I mentioned the modular design that we have. With that modular design, a huge benefit to the customer with that is it helps us as far as having downtime on the equipment, because what it does is it allows the system to be able to basically, if we have a power module that fails within a power unit, or we have a certain channel that goes out within a power unit, the system is able to adjust to that, so the end user may never even know that the failure has taken place. It also allows us, from a repair standpoint, a service standpoint, to be able to go out there and very easily switch out these modules when they fail to improve uptime for the customer.
Okay. So this is where it will happen, like right
Yes.
here on the floor.
Yes.
So have you started building here?
We have been manufacturing here. You'll actually, when you make your way a little bit further down, you'll actually see our production boards down there that kind of show what's in process right now. We can kind of look around. So we have us basically on the line right now are 3 double cabinets that are going out to, it's actually 2 different customers that are on the line right now, both of which are getting double cabinets.
And you can't tell us who they are?
No. So basically down here at the end, this cabinet has already been merged together. So basically single cabinets come down the line and then we combine them together at the end. But yes, all I guess it's actually 6 single cabinets, but come together to make, it'll eventually be 3 double cabinets that are coming down this line right now that are in the process of manufacturing.
And how many can you build with this setup right now, and what are you scaling to?
We're still very much in the scaling phase.
Yeah.
We do have numbers out there. I'm not sure how much of that I suppose I can share.
So maybe I'll look up the numbers to make sure that
that would be a
I
better
don't put
question for you to
in
ask.
Yes, someone else.
Someone else,
Okay,
yes.
for sure. But
yeah,
I mean, you want to be able to. This is your only manufacturing plant so far in the U.S.
Correct.
And perhaps you would scale somewhere else. But let's start here. Let's get it up and running.
Yep.
Okay. So
I can tell you, we just recently added a second line to the power units.
Okay.
So there's actually another line on the back side. It's kind of hard to see from here, but there are 2 lines now for the power unit production.
Interesting. So maybe it might be a question for someone else as well, but if, someone puts in an order, of course it depends on the magnitude of the size of the order, but how quickly are you trying to, make these timelines so that you can get people these?
Again, we do have a scaling process that we're trying to stick with as far as like forecasting and customer orders and all that. Marcus would probably be the best person to get more info on that as far as like what we're allowed to share and what we're not allowed to share at this point. But he would probably be the best person to give that information.
And who exactly are the kind of people on your team? Are they engineers, electrical engineers, mechanical engineers?
For the assembly process is primarily people that already have previous manufacturing experience. Right now, because we are kind of new as far as a manufacturing facility, we're really targeting when we do our hiring to get the at least mid-level people as far as their experience and education and everything, at least mid-level. Testing, we do require a higher education and everything on the testing side of things. But we're in a prime area as far as the universities around here, the community colleges around here. We do focus on the assembly side with people with more of a mechanical background, whereas test is more of an electrical background, not to mention due to the voltage levels that we're operating at. Electrically, we want everybody to be safe for sure, so we want that experience in there, just primarily in large part due to the safety standpoint of that. We want people that have experience with the higher voltages and all. So.
Makes sense. Okay, cool.
But yeah, we have been working on establishing partnerships with the local community colleges and the universities.
Research triangle.
Yeah,
right?
I mean we're right in the prime of it with UNC and Duke and NC State. All of them are within
Yeah.
30
I mean,
miles
that's
up here,
certainly a
so
goal, is
then-
not only build America,
Yep.
buy America, but
Yep.
make more jobs, especially in this industry,
Yep.
and bring it within the borders.
And we have Durham Tech and Wake Tech, both very close as far as having some more of that technical expertise that we can tap into outside of the universities.
So we found ourselves now along the tour at the testing center, right?
Yes.
Okay, can you introduce yourself to our audience?
Hi, I'm George Gear. I'm a test engineer here at Kempower. I've been here for roughly a year now. And
What do you do over here?
so this is where we test. So we have two different areas of the testing cage here. We have a pre-test area. I won't use this to point, I'm sorry.
That's okay.
We have a pre-test area here and a final testing area over to the left. Pre-testing is our first line of defense in quality assurance. It allows us to verify workmanship and most connections in each power unit. By identifying and addressing any issues early, we can save time during the final testing phase. Pre-testing can be done in parallel with final testing to maximize our productivity. After pre-testing, each power unit undergoes a mostly automated final test. This is where we thoroughly check all functionalities, and I will break down the final testing process for you.
Yes, please.
So first, there's a high voltage safety test, which we can go up to 3.3 kilovolts, and this is why we have the test cage. It helps to ensure the safety of all of our employees. All of our technicians that are allowed to work in the cage and be in the cage have undergone electrical safety training to handle these tests safely and effectively. Next, we have high power testing to verify that all connections are correct and properly torqued. This ensures that the unit can handle high power loads without any issues. After that, we set up and program the control module so the power unit can be integrated with our ChargeEye software. This setup is crucial for the unit's operation and monitoring once deployed. Finally, we test the unit's ability to connect to the internet, which is essential for real-time monitoring and updates. All these tests are documented and traceable through our tracking database called Watts. This helps us maintain consistency and quality across all of our facilities, as the same testing procedures and standards are applied to all of our facilities globally. So we're doing the same testing here that we do in Finland.
Great. Probably, stick to what you know.
Yes.
In that case.
Yes. Satellites, units, and other various modules all undergo very similar testing processes to the power units. By functionally testing 100% of our products, we ensure that every power unit and satellite meets our high standards before they reach our customers.
Great. So this is obviously pre-testing. You make sure if it's going out, it's going to be reliable and
Yes.
safe,
Yes.
of course. That makes sense. But once they leave your station, do they ever come back, or you're just
They don't come
one
back
step
here.
along the way?
Come back here. No. So pre-testing is something that, like I said, it checks most of the connections between all the modules in there. If we have any issues with that, then we either fix it here or we bring it back to the floor and have them fix it. It depends on what the issue is. Once it's done pre-testing, it goes to final testing, and when it goes to final testing, it takes some time to set up, which is why we do the pre-testing first. Because if it's a simple problem, we don't want to have it get to final test and then find out that we have to disassemble all of the testing cables and whatnot to bring it back out. So once it goes there, it gets tested through final test. Like I said, it goes through. We do 100% functional testing, and then once it's done that, it goes out to packing and shipping.
Okay. What are the typical issues that you might find here?
Most of our stuff here is usually wires in the wrong spot, things not torqued correctly, that type of thing. It's mostly production issues, and most of them are very easy to fix. The units that come in here that we test, and the modules that come in and that we test are all tested in a different area. So those, when they come in here, are good. We know that those are good, and we're not worried about the problems with those.
Okay.
So,
What is the background of the folks that you have in this pre-testing area?
they, like I said, they've all been trained with electrical safety in mind, to make sure that no one hurts themselves or gets hurt.
Yes.
Besides that, we have some people that have been in the, I would say, electrical field for many years, and some that have not been. It's a mix.
Okay.
It's a mix.
Great. Okay. Super cool. Seems like the fact that it is such a modular design might be helpful as well with the pre-testing.
Yes.
Because it's not all interconnected. And if
Exactly.
there's something wrong, then you could fix a part rather than the whole.
Exactly.
Great.
And you can see here, as I put, these are the modules that we use for pre-testing. So right there, all the lights are on. That means that all the connections are good.
And so I know that you're kind of looking at within, the power unit, the cabinet.
Yes.
Do you do testing with vehicles at all here with EVs?
In this facility, no.
No.
I don't know if we do with other facilities, but we do load testing here.
Okay.
So we are testing to make sure that our products can handle the load that we need it to.
We are continuing on to our next stop along the tour. I'm joined by Kevin, who I just recently saw at ACT, ACT, whatever people call it. I like to call it ACT.
Yeah.
Where we were looking at, you debuted the Megawatt Charger there, but what do we got going on here? Which station are we at now?
Certainly. So you're at the satellite charging system station. So the satellite charging system is really one of the key features of Kempower's product offering. This is part of a distributed system. What I mean by that is we have a centralized power unit, and then we have distributed dispensers, which we call satellites here at Kempower. These satellites provide charging ports for vehicles, and we can support up to 8 ports for vehicles to charge. And typically we'll see 8 ports in a fleet charging application or up to 6 ports in a public charging application. One thing to note about our satellite is really flexibility, and that's part of our system design. What I mean by flexibility is that the system allows you to support a wide range of vehicles is one, whether you have CCS or NACS or CHAdeMO, but it also has flexibility from site design perspective. So we have the ability to provide satellites in multiple places that are attached to the same power unit, a centralized power unit, if you will. One example to illustrate that would be a car dealership. For example, we could have satellites back in the charging bay, or in the service bay rather, but also at the front of the house to be able to support charging for convenience charging for customers. And you can do all that with the same system. So it really helps you utilize your investment for multiple use cases, but also that grid connection. You can use a smaller grid connection overall instead of having to have dispensers that are rated or charging systems that are rated for a certain level. And overall, you might have a higher amount of power that's prescribed for the site, but using one centralized power unit, you can actually reduce what that power for the site is required to be, and allows you to really utilize your investment in available power more.
Very interesting. Yeah, it's more of like a web design than like a linear design of power straight to one dispenser, but instead many. And I think that's a good way of painting the picture of that. Is like, if you look at this dispenser as well, and the footprint is pretty small, but if you think about the wider setup that you have, it's quite a large footprint, but it's a little bit undercover. So I think that's a nice design personally, because it does seem to take advantage of no matter kind of the kind of site that your customers have, they can try to use this. So I like this. Can you tell me a little bit about the cable management system that you have here? Speaking of webs, it does kind of look like a spider web or spider legs.
Certainly, it is something that's pretty unique in the industry, and something we're actually pretty proud of. So this is our spring-based cable management system. And as far as the cable management goes, it allows you to really be able to manipulate the cable in a way that's pretty easy. So instead of the user having to take the felt weight of the whole cable, the spring supports the majority of it. It allows us to be able to stretch it and pull it. So you can also stretch it and pull it in a way that will bend with wherever you need to take the cable. And then when you return it, it still takes the majority of the weight of the cable off and allows the user really to have a better experience to be able to use the charging cables. Now we do utilize dry cables often in this system, and pretty high current cables, which allows us to really have a product that could be cost effective, as well as one that might have lower maintenance than liquid cooled. Of course, there's certainly a great place for that with liquid cooled cables. But in this system, we at least can help improve the user experience for a variety of cable types to allow users to charge more easily.
Okay, great. Can you tell me a bit about what I see behind you? This seems to be like the workstation for the satellites.
Certainly. So with our satellites, we do have some of our production line here that you see in the back. Now, I'm not certainly a pro on exactly how our production line works behind us, but you can see one there that's currently under construction. And we do a lot of assembly here in this facility. So we have parts that we source or that we provide through our supply chain partners, and then we assemble them here. And so certainly in this area, we're able to do the assembly of these satellites. Now we also have areas that are behind us as well for various testing that we do on both the satellites as well as the power unit as needed. So these facilities really help make sure that we have a quality product that meets our test specifications before it leaves the factory.
I see a lot of negative space. I'm excited for y'all to fill it up.
Me too, of course. So as you notice, we do have room to expand, and this facility is just one of 3 that we have here in this local area. So we do have footprint that allows us to expand as our North American production ramps up, and then certainly if we need to expand more, we can certainly do that. By using the footprint, or I should say the blueprint for our manufacturing in Finland, we've been able to replicate that here in North America very rapidly. And we have the ability to do that again and again if needed to scale our production.
Great. And so if I look closely up here, of course, this is what we call a dummy charger, right? Or
correct.
Satellite.
And that's right.
But I see the 800 volt architecture and the 400 volt as well, and then 120 kilowatts or 225 kilowatts. Can you tell me a little bit more about what people will be able to see? Like, this is exactly what they're going to see if they pull up to a Kempower station one day soon?
That's right. We do have some configurability in the screen, in the display, and we even allow our partners, our CPOs that are operating the station, to be able to customize that. So you might see some variation from the actual charger that you see in the field, but this is exactly what you could see. In the case of this one, we have 2 different powers that are shown to give the consumer an idea of what power they would get for a 400 volt architecture vehicle or an 800 volt architecture vehicle.
If they know what they have.
Exactly, if they know what they have. And so we actually simplify this often and just show one power level so that it's a little easier to interpret for the consumer.
And I see you can, go ahead.
Go.
Well, that you can tap an RFID card or whatever, but how do I pay here?
How do you pay? So that's one, like you said, RFID is one way to do it. You could do it through a CPO app. So we integrate with many different platforms depending on who is the operator of the product. We also support plug and charge. So that's something that we could interface with. Certainly the operator of the network would have to implement that, but we have the ability to support it, and we do in Europe as well.
Very cool. Anything else you want to note about the satellites?
Maybe one last thing that I would like to show. So it just shows you a quick authorization of what the handshake might look like. But there's one feature in particular I wanted to show you about our satellite, and that is the ability to see real-time status of your charging from your phone. So just in a moment, we'll see a QR code that pops up. So you say follow on with mobile. So I can take a picture of that with my mobile device, and I can see real time what my charging status is.
Without having to download an app.
Exactly, no app required. It's all web-based.
Good.
It's very nice. So you can take that status with you. You can see all the great statistics that some people like to see with the voltage of the battery voltage of the vehicle, the charging current, the status, etc. So really a lot of power in your hands, at least for the consumer, especially if they want to know a little bit more about what's going on. And the last thing to mention is that we have the ability to show the consumer what is actually limiting their charge in real time if our CPO wants to enable that. So what that means is we can say that we can show a message that says that the utility or the grid is limiting a charge, or we can show that the vehicle is actually limiting the charge, because a lot of times it's not just the charger that's at play with the limit. It could be the vehicle or some other issue.
Wow, do you already do that in Europe?
We do that in Europe today as well, and it's a standard feature with our ChargeEye backend. We don't always enable it on the satellites, though. It's really up to the CPO if they want to enable it.
I would say they should. The more information, the better from our point of view.
Agreed.
That's really cool. I think that would be enlightening for a lot of people. Speaking of enlightening, I see you have a light here. If we're just looking at the actual setup. Is this does it change if it's charging? Do you know like if it's being used?
Right now we're using it for illumination primarily, but that is something that we're looking into, is being able to use that as for status indication, especially being high up. And then certainly illumination for our charging handles here, maybe improving that in the future as well, is something that we're looking at, especially if it's dark in certain areas.
Folks, you might recognize my next guest along the Kempower tour. Do you mind introducing yourself and your role at
Hi,
Kempower?
of course. My name is Sumaya Youssef, and I am the product specialist here at Kempower North America.
Yes, and you were on a podcast before. We did a series on Kempower.
That's right.
And you spoke a little bit, but that was in 2D world, and now we're in 3D world. So it's great to
Yes.
see you here. Okay, I see what we have here in front of me, a power cabinet. What do we have going on here?
All right, so today I'm introducing you to the power unit, the heart of Kempower's distributed charging system. This is the unit that provides the necessary power and control to ensure that the charging outputs have the supply of power that they need in order to operate. And in the distributed charging system, which you can see here, this power unit, I always say the best power unit is the one that you can't see. It's further away from people, you don't interface with it, and it remains in a safe, protected place, because you'll find that our most advanced power electronics components are housed inside of the power unit. So each one of these units that you see here are a power module. Each of these power modules are rated at 50 kilowatts, and each of these 50 kilowatt power modules contain two independent 25 kilowatt channels. And so this granularity of being able to distribute 25 kilowatts of power and add on to that is what allows our distribution module right here to intelligently allocate all the available power to the charging vehicles. So if a car pulls up and it requests 50 kilowatts, it's going to get 50 kilowatts. If it's requesting more than that, 100 kilowatts, 200 kilowatts, 300 kilowatts, you'll be able to allocate all of that power, assuming that there are no other vehicles charging. But if there are other vehicles charging, you can charge simultaneously in parallel and allocate the available power based on each vehicle's demand. And so let's say you're at a place where you have a smaller charging site and you want to start off with just one 50 kilowatt system. You can still plan ahead and future-proof and have here we have featured the triple door cabinet system. So let me move this door right here. Our triple door cabinet system. It's our largest one, but it also comes in double door and single door cabinet configurations. The triple door cabinet system can, if you do the math and you take 4 of these power modules and multiply them by 3, that's 12 power modules at 50 kilowatts each. That's 600 kilowatts total. And you can start off with just one at a time and add more as you need more and as the site expands. So that also includes situations where you might not have sufficient grid hosting capacity. You can add more when you need more because the infrastructure is already there. And suppose that one of these power channels goes down or a power module goes down. Your entire power output is reduced only by that particular amount, and the remaining power modules remain operational. This system redundancy enables us to have such high uptime, and also because of the ease of the design, it allows us to quickly swap out each of these power modules in a situation where you just pop one out, pop one in. It takes like a 10-minute job. And you can also ensure that as new power modules are released, when we release new tech, you can also upgrade very easily because it'll retain the same form factor. And so you can ensure that the entire system has a longer lifetime while also ensuring that you have a longer charging uptime as well. And that's something really unique about our system that makes it really special, and just it makes sense. It allows it to work really well.
Definitely. I mean, with not only site hosts maybe being unsure of how much power they can get or how much charging they're going to do on their site, hopefully they have a good business case for it, but the scaling up I think is a really great option to have, and the modularity continues to make more and more sense. Down here I see Ethernet. I'm thinking about diagnostics. Of course, if someone does have to come in, can you tell me a little bit more about what's going on here and how someone could detect that something's wrong with the system and then come out and treat it?
Awesome. Yes, absolutely. So we talked about the power modules and the distribution module. Right beneath it here, we have our control module, and right beneath it, the mains module. So the mains module is where you have the switch and the main circuit breaker. And the control module, this is what enables communication. So you'll see there's each of our control modules comes with our own SIM card for cellular capability, but you can also add your own if you prefer that. We also have hardwired Ethernet connection and Wi-Fi as well. So this is our, think about it as the brains of the system, and it's connected to our OCPP backend. And for us, our system is ChargeEye, but we can also integrate with third-party backend charging management systems as well. And ChargeEye actually began. I don't want to talk too much about ChargeEye because our ChargeEye folks will tell you a lot more about that. But it's what really enables our remote diagnostics and troubleshooting capability, where you can just do so much without ever having to leave your office.
Wow. Cool, great. Can you tell me, because I don't know exactly how tall you are, but how big is this so that our audience can know, like, how big are these cabinets?
So here I am standing next to the power unit. I'm about 5'7".
Okay. A good maybe 6, 7.
Well, it is on a little pedestal,
It is
so
on
I
a
guess
little
if I stand on here.
Yeah. Maybe 7 feet or under.
Yeah,
Between 6 and
something
7.
like that. I mean, if we want to get look at this particular specs, we can pull up the data sheet and take a look at it. But it's amazing, really, how small our footprint is, because the largest part of the system, the power unit, can be placed up to 80 meters away. So that's about 262 feet away from the charging units where the vehicles are charging. So they'll never even notice it. Like, we'll have people come up to us thinking that our satellites are level 2 chargers without realizing that actually these are powerful level 3 DC fast chargers, just taking up a small 1 foot by 1 foot footprint.
Yeah, we were just talking about.
We're able to do that because this power unit can stay further behind and manages the available power just like a bank would.
Can you tell me a little bit more about why it can be so far, how it can be so far, and maybe why we don't see that with other models?
Yeah, so there are advantages to all-in-one systems as well. So I don't want to underplay the value of the all-in-one systems, because in some applications the all-in-one system makes the most sense. Because one thing that you do have to consider when you're having the distributed system, it's not a bad thing, it's a good thing, but it depends on the particular application, is that you actually have to connect the DC conduit from the main cabinet to the charging satellites.
Could be pretty far away.
Which could be further away, right? And so that's an additional cost that you have to account for. But in a situation where you have a charging hub and space is a limitation, it may become worthwhile to invest in that extra cost to ensure that you have kind of an optimal, flexible site layout. Whereas if you have an all-in-one system, you kind of forego that. You don't need the DC connection that is fed from the power electronics directly to the charging outputs.
Yeah.
But then you forego there's the space limitations as well. And it's also kind of louder and a little bit more. There's just a lot more going on, and you're not efficiently utilizing your grid connection.
Right.
So it's a trade-off always.
It is. It reminds me of how a lot of chargers are in the back of parking lots, and then they're right next to the power units or the cabinets. But perhaps you could have them closer to the front of the store, thinking about not only that's just convenient, but also ADA and other sort of compliances, and have a bit more of a better, less isolated setup.
Yes. And in situations where let's say you have a gas station and the gas station wants to be able to offer electric vehicle charging, a lot of the times they really have some serious space constraints. So a solution like this would be ideal in a situation where you have very limited room to build up.
Exactly. Thank you so much, Samaya.
Of course. And by the way, if 600 kilowatts is not sufficient to meet your power needs and you need more than 600 kilowatts, at our next station, my colleague Adam will tell you more about our Megawatt Charging system, where we connect 2 of these power units together and get a whopping 1.6 megawatts of power. So
perfect transition.
Talk to him and learn more about how we can charge those massive trucks.
You might recognize this face if you're tuning in on YouTube. If not, this is Adam. We were at ACT the other week in Las Vegas, where you were showing me this, which is your Megawatt Charging system. Of course, we covered that. You were unveiling it at this, but now we're at where you're going to be building these. So tell me a little bit more about this, maybe a brief introduction of, what you're going to be able to do with this setup.
For sure. So we just introduced this to the North American market It's the Megawatt Charging System, 1.2 megawatts. That's 1,200 kilowatts. That's a lot of power. To put that in perspective, we had a utility in here the other day. They said every 600 kilowatts added to the grid, they see that as a Walmart supercenter. So this is 2 Walmart supercenters going into one vehicle at a time. So how we do this is actually through the existing technology we already have. So it's nothing new. We're not reinventing the wheel. It's hooked up to 2 600 kilowatt power units. So what we already do today, and we do it very well, we're going to continue to do this. And this is just a new type of dispenser. So it's just adding a new satellite to our fleet of dispensers on how to dispense power. It's using the MCS charging standards that aren't fully released. They're in the white paper stages right now, but we're following along very closely with that and waiting for some OEMs to release some vehicles for us to begin those high power charging sessions.
So is this technically like a 2-door in a different casing?
Yes. No, it's actually not. It's a completely different setup.
Good.
We kind of thought it was going to go that way to begin with, but the engineers over in Finland decided elsewise.
Yeah, why not?
And yeah, super compact. In the charging standard, from what's been defined already, when a truck driver, Class 8 vehicle, gets out of his vehicle, the charging plug is always going to be right behind him or him or her to the left, on the left side of the vehicle. So this charging cable does not need to be very big. They're always going to pull up right next to it, and it's going to plug right in.
So that's going to be standard on heavy duty, but not on passenger vehicles.
Exactly. But I don't think many passenger vehicles are going to need this much power, thankfully. Yeah. But yeah, a lot of power going in. And what really makes this system unique is while it can output 1.2 megawatts, it still has that ability to have that wonderful Kempower dynamic charging. So you can hook up 8 additional satellites to the system. So you can have the NACS, CCS, CHAdeMO, all those also connected to the system. When this plugs in, it'll likely take most of the power, but all the additional power will get shared through all the other satellites. And then once this unplugs, all the other satellites go back to normal operation.
Okay, interesting. And so within this power unit, but it's a mega,
this is just a dispenser.
Just
mega dispenser.
Okay,
yeah.
mega dispenser. Okay, understood. So this is a large satellite.
Exactly. This is just a new satellite in the Kempower portfolio.
Okay, really cool. Great.
Yeah.
So then it would be hooked up to something similar, but not exactly what I'm seeing behind you?
It would hook up to exactly what you see behind you right now.
Okay,
yep.
great.
So, which makes it awesome that something that you install today is MCS ready when you're ready for it. And so all you need to do is make sure you have 2 600 kilowatt units on site. So you can install one today. When you're ready for MCS, install a second one, and then just add this dispenser, and all of the existing infrastructure still is there and still can be utilized.
When it comes to megawatt charging, is there stuff that you're seeing in the North American market that is exciting, where you're like, okay, we're moving that way?
Yeah, honestly, we've been having a lot of really productive meetings with mining operations companies who have very unique use cases, and just seeing how their challenges and struggles can be solved with this, and how it's not just Class 8 trucks, it's the entire industry, the mining vehicles, farming vehicles, everybody can use this system, really.
Pretty cool. Would love to see more and more of that, especially because electric vehicles requires a lot of mining. So might as well work it into the whole system in a circular fashion.
Yep, circular economy, for sure.
So these will be built here?
Not for the beginning. They're going to be built in Finland, but yes, eventually this will become part of the U.S. portfolio.
Okay, and so I know, Build America, Buy America for NEVI. What about for Megawatt?
Yeah, it's more of when we see that request come through, is we will bring it over. Okay. So it's kind of waiting on that time frame of when someone asks for a BABA MCS dispenser. I think that's when we're going to get it.
Interesting.
Yeah,
okay, that makes sense.
We are, it's not terribly a lot going on in there. It's more less just a dispenser with some liquid cooling. That is something we have the capability of doing.
They're all going to be liquid cooled?
Yeah, this is a liquid cooled system. Yes.
A lot of power.
Yes. So if it wasn't liquid cooled, this would probably be at least double the size of cable, and that wouldn't be bendable at all.
That would be
yeah. So liquid cooled system. We're going to have other air cooling in there as well to get heat out of there, because at the end of the day, we're all trying to battle heat, and that is the killer of power electronics.
Continuing on the tour, this is where we had the Q&A session. I'm now joined by Rhett. And can you tell me where we are?
Yes. All right, Francie. So again, Rhett Kaiser. I am the ChargeEye product manager for Kempower.
Okay.
Are you familiar with ChargeEye at all?
Tell me. I think I know what ChargeEye does, but I don't know about our audience too.
Okay, great. Yeah. So ChargeEye is essentially Kempower's charge management system. And I guess a little bit of history, how ChargeEye came about. People pull up to charging stations and they want them to work, right? We know that this has generally been a problem in the industry. And one of our ways of kind of solving that problem is remote diagnostics, right? So ChargeEye was essentially built as a tool by engineers for engineers to remotely troubleshoot our solution. And I can actually show you within the power electronics, like kind of how the data starts to flow, right? So right here we have a cabinet that contains a bunch of power modules, right? And when these things are shipped from the factory, they come with a SIM card installed in them. So when they're powered online, data flows between kind of the brain of the operation here up to the internet, up to the cloud. And it tells us things like, hey, in module 2, we know that channel B is not working. So, and it notifies the operator essentially, right? So with that, the rest of the modules are still working, but they're reduced, or the total power is reduced. The end customer doesn't necessarily know, hey, it's not working, but the operator of the charger wants to know, and they want to be able to go and swap it out, right? So essentially, information is flowing from our satellites and the vehicles to this kind of brain here, and then it's sent up to the cloud where we can kind of get into the more advanced diagnostics.
Okay.
Any initial thoughts, questions, or?
Yeah, I mean, I know about drives. Basically, that's the platform that I know most about. So, can you tell me a little bit more about why you chose this iCloud? No, iCharge.
ChargeEye.
ChargeEye.
Yeah.
Thank you.
Why ChargeEye for Kempower? Great question. So I guess it started by engineers for engineers. We could monitor remotely, but it's kind of evolved over time, right? The market's asked us for things like, hey, we want to incorporate credit card terminals into your chargers so that customers can go up, tap the credit card, and pay. Or we want to be able to use the satellite as kind of a marketing tool for our operation. Like we want to be able to put our brand on it, right? So we can do custom displays and stuff through ChargeEye for a public charging network. As a consumer, you want to know where Kempower's chargers are on the map, right? So ChargeEye actually enables getting our chargers on maps like Google Maps, Apple Maps, popular vehicle manufacturer navigation systems. So that's kind of one of the features that's evolved over time with the market needs, right?
Mm-hmm.
We also have stuff in the fleet segment. I can jump around.
Love talking about fleets. Yeah.
Okay. Yeah, so with fleets, the big thing is power, right? Our CEO, Tommy, earlier was talking about one of the biggest costs for fleet customers down the line is going to be power. And in the States, how can we kind of help our customers address that issue or drive down their costs, allow them to pay the least amount of money for electricity? So we've seen that in general, the grid here, or the way that electricity is charged to the fleet operators, is on peak usage.
Mm-hmm.
So if you have an energy or a large energy pool of like megawatts, right? It's super important for these operators to be able to essentially drive down peak usage. So ChargeEye, we can input information like, hey, we know there's this, say, set of 20 delivery vehicles that has to go out on these specific routes tomorrow. We know what their planned routes are. So therefore we can say, hey, they need to have this much battery to be able to meet that route. With that knowledge in mind, we can essentially use an algorithm within ChargeEye to say, hey, go ahead and smooth the curve of charging so that you're not kind of exceeding those peak values over time. And we've seen like pretty drastic reductions in energy usage for sites just utilizing that information.
Yeah, that makes sense to optimize it so you're not getting those demand charges.
Yeah.
And being charged for the rest of the month or year or whatever it is.
Exactly.
Okay, great. Is this the software, the management system that you use just in North America or also back?
It's used globally.
Okay.
Yeah.
Great.
So originally, of course, started in Europe, but as we've transitioned into the North American market, we've kind of kept things in mind here, like, what differences might there be in the market here from a software perspective? How do we meet certain kind of regulatory requirements and whatnot? And a lot of those needs are kind of software driven, right? So as we have developed here, that's been kind of a huge piece of what we've been thinking about, kind of the brains or the behind the scenes, right?
Yes. So how do you continue to make sure that this is the right software for you to use?
You being like the
Well, I mean, what are I guess, you're always testing the chargers. How do you measure the success of this management platform? Is it like how quickly that you're getting uptime? Like, does uptime have to do with it? Is it
sure.
success in management,
Yeah, no, great questions. And I think ultimately it depends on the customer's needs, right? So depending on the segment, it's like, hey, what are your key pain points, right? Of course, uptime's huge. That's a big thing for a lot of our CPOs as well as fleet customers. But that said, I think it's just developing with market needs, listening to the field. We get RFIs, requests for information, that sales essentially funnels to us. And if we start to see overwhelming, hey, like, do you guys have this or do you have that? We pay attention to all of that and kind of keep it into account and build it into our development roadmap if it makes sense.
Totally makes sense.
And from there, something that's really cool because we've been in Europe for so long. Europe's probably 5 years ahead in terms of like the electrification of, as I'm sure you all know.
Yeah.
I see you nodding. So we can learn a ton from what's happened there in the market, right? Which is a really, really cool insight that we have in this space, right? Just
That
being
experience overseas.
exactly,
Yeah.
exactly. It's been great just kind of picking their brains. And like while there might be some minor differences, I think like certain things around standards and for example, vehicle preconditioning. If you have a school bus that is about to go on a route the next morning, you want it to be warmed up for the driver and the kids
Mhm.
to be able to get in there. There's a standard in Europe that is called VDV 261. Not to get into the weeds too much, but
We love the weeds.
yeah, essentially, the charger itself can plan a preconditioning schedule around a vehicle by communicating with that vehicle, and it doesn't kind of drain on the battery at all in the vehicle, and is actually ultimately better for the lifetime of the car. So,
Yeah. Optimization is key,
no doubt.
as well as, management and customization. So it sounds like that's a lot of this software. Yeah.
Yep. Optimize, collect data, and continue, iterate, right?
Yeah, of course. I can imagine, you have the same goals in Europe that you do over here, essentially, which
Yeah.
is create a charging system that works.
Exactly, exactly. I have actually a live demo of a charging session over here on ChargeEye.
Sure.
And it's pretty interesting. This would be what it would look like for this Model Y. Well, right now it's actually a Kia EV6 that you see on the screen, but it might flip back to the Model Y.
Yeah.
We were trying to have like kind of a live hookup, but power restrictions due to some safety stuff made it so we had to kind of do a demo here.
Sure. Makes sense.
But essentially what we're looking at is a live view on the cloud of simulated live view on the cloud of what a charging session would look like. So you can kind of see the power curve over time as well as the charging power that's being used. So you can see the blue line is the state of charge. There's kind of a predicted dotted line. Hey, like we expect this is how long it'll take to reach this state of charge. You can kind of see the clicking around there. Actually, you can see satellite 3 is the one that's pulled up right now. Full list of satellites that are attached to this particular power cabinet. But there are 2 charging sessions going on simultaneously. The one that's right here in finishing state, as well as this blue one right here. So it's cool because you can kind of see how that dynamic power sharing is going on. And
Cool.
just looking at the 2 different curves over time, it's like, oh, we see a new vehicle. Let's shift some power over to this car.
So is it pretty live data?
Yeah.
Yeah.
Yeah, super
Lot
real
of-
time.
A lot of API calls.
Yeah, so the communication to the cloud is generally done through OCPP,
Okay.
industry standard protocol.
Yeah.
But we do have APIs that can be used to pull data down. If you were to say want to manipulate any of the data for troubleshooting or like finance projections or all kinds of stuff. Like one of the things that ChargeEye is kind of touted for is its abundance of data that's collected from our chargers. And because we're the charger manufacturer, being the operator of the CMS, we actually kind of go above and beyond that OCPP communication. Again, designed by engineers for engineers. So it kind of gets into the weeds of kind of this custom level code that allows you to see like specifics into the power modules or like faults that you wouldn't otherwise be able to see on other companies' chargers.
Do you mind introducing yourself?
Yeah, so my name's David. I'm one of the service engineers here for Kempower. I guess we can call ourselves like remote first. We're the guys that troubleshoot the chargers, figure out what's going on, how do we fix it quickly. And yeah.
That's great. Good job.
And my name's Christian. I'm the logistics manager here. So everything from our order taking operations, internal material handling, packing, and outbound shipping is kind of what we touch here. So, but
Great.
behind us we've got a beautiful Volvo excavator. This is kind of their mid commercial range excavator. It's going to be fully electric, and the great thing about this is that all of the systems, the hydraulic systems and everything, function exactly the same as the diesel engine. The only difference is how it's powered. And there's a lot that comes with that. When you change how it's powered, you get obviously no emissions, no vibrations, which is a great benefit for the operator. They're not going to be sitting there having all of these kind of vibrations throughout their entire body while they're working on an 8-hour day. And then also the sound, especially when you're talking about urban development, there's not going to be any kind of noise pollution for the neighborhoods and environments around you while you're kind of going and doing this.
Big plus, of course, but the challenge is charging, right?
Right. But there's an advantage too. So if we go around and look, we can kind of see the charging port here. This machine will use the same CCS port as any of the cars that or trucks or any other kind of DC fast charging machinery that you've got. So the idea is that you could install these chargers right at the beginning of construction, as you're moving the earth and getting the land prepped, and then plan it so that it's in the same spot at the end, and you hook cars up to it after the end of it. So this really can be the Kempower charging solution can be the first thing that you put into a site, and it powers everything from the construction to the end user use.
So need a little bit of forethought there.
Right.
Yes.
But the less you move, the less you spend. You can put it in when everything's fresh. You don't have to work around anything.
Yeah.
And then you've got a sustainable power source throughout the whole construction process.
Be able to use that asset before you, I guess, make it a part of your business model.
Right. Yeah.
On
Offset
who you
costs.
are, right. So
right.
Typically, who would be the customer for this kind of setup?
So right here we've got our movable charger, and I'll kind of hand it off to David to kind of talk a little bit more about the capabilities of this.
Yeah, because we've been looking at the ones that you put in the ground and you leave them. This is the movable one.
So essentially, the easiest way to explain this, it's the same exact thing as the power cabinets, just in a smaller package. It's the same software.
A lot smaller.
Yeah, same software, the same internals as well. It's just in a more, we say it's a movable package, but not quite portable. Obviously, the input here is 480 3-phase. So we do, could have some setup limitations there. But essentially, this is the same exact charger in a smaller package. So a lot of our partners and clients really find a lot of value in using the movable chargers as an introduction to what we can think of as the whole Kempower ecosystem. We're running the same software, same power modules and internals as the larger stuff, like I keep saying. But I think there's a lot of value in this application for some sort of fleet charger that's just starting out with maybe a medium duty international trucks. What is it? EMVs, whatever they're calling it right now. That might be incorrect. Don't quote me. But we definitely have clients that have these, and then they're able to configure their charging through the software in ChargeEye that hopefully you've just seen, because you just came with Dan, right?
Yeah.
Or with
Rhett.
Thank you. And then they really do use that as a springboard for proving out their proof of concept, proving out what they need to learn, and how it works for their operation.
And the uptime is still very powerful with these movable chargers. Even though there's one power module, the power module is set into two different sides, and it can fluctuate the same thing. So this unit together will kick out 50 kilowatt hours.
As long as it has that power on site.
Yeah, on site, right. And then, but it's broken down into two phases, 25 and 25, and they work independently. So even if there is some sort of kind of malfunction on one side, you'll still get at least that 25 kicking through that other channel. So that kind of redundancy that we have built into all of our products is the same even on our smallest unit.
I mean, I've heard about these kind of, maybe not portable, you said, but
We say movable, not portable.
Yeah, so what's the difference exactly there?
I think the reason why we say that is just it's not designed to be a true mobile charging application.
Like moved around a lot?
Yeah, it's really. We have some partners that do that and have developed their own solution for it, and it works pretty well. And it actually works very well. But like we haven't gone through and redesigned the entire product to stand up to vibration testing, on a trailer if you're pulling it behind a truck.
Sure.
And I mean, we certainly could do that, but
Maybe one day.
yeah, as we, let's say, as some of the battery technology and all that stuff, and how we spin up that partnership that we have going now, we can talk about that kind of thing. But then there's other like weight considerations and all that kind of stuff. But
Yeah, so partnerships?
yeah, did you want to hop in?
Yeah, and I'll just kind of mention that as electrification goes through many different products, this could be potentially, once the technology gets to where you could even plug this up into an electric truck and use that to convert the power over into a different kind of vehicle. So, and that's where a lot of the mobility and flexibility in this unit can come into play, especially for construction equipment, because you're already going to have work trucks out there. So you have an electric work truck, you drive it out to where you need it. Let's just say you want to kind of take your time with the implementation, so you're not going to put something in the ground. Well, you can hook this up into your truck as long as it has the adequate power to run the unit, and then put that power from the truck into the construction
Vehicle
equipment.
to load.
Yep.
Yeah, okay, interesting. Yeah, just moving power around.
Exactly, right. We've gone from getting the certificate of occupancy in November of 2023 to what you're seeing right now.
Yeah,
and
that's
we've already
fantastic.
produced and shipped in both the U.S. and Canada.
That's pretty great. And I know I asked earlier, like on the Q&A session, about partners, and a lot of those can't be spoken to. But can you speak to some partners for this model, or what were you going to say about partners?
Well, for partners, we'll leave that. All that information can be found on our website and in our feeds, because once kind of we can go public with that. Yeah, we'll put that right. So. But we can tell that, especially from ACT, which I'm sure you guys were involved with, that we've had a lot of interest, and just the momentum is strong in the electric sector. Well, and talking about running, you might want to be interested in checking out the Nitrocross car that we have set up here.
Yes, definitely.
Which
Can
is
you tell me
all
about
electric. I'll
pass it
hand
on
you
to
off to the professionals. They just let me play around in the dirt, but these guys get to race. So
Amazing. Thank you.
yeah, no problem.
Yeah, thank you both.
So here we have Eric, one of our great sales accounts.
Francie, nice
Francie.
to meet you.
Big fan.
Ah, thank
Yeah,
you.
man.
Thank you.
Yeah, nice to see you.
Nice
Thanks
to see
for
you
coming
too.
out.
Yes, thank you for having me.
Yeah,
so I'm
absolutely.
continuing on the tour. You've been handed the mic. It's your turn to take the
There you go.
stage.
Well,
Where
again,
are we now?
so I'm very excited. First of all, thank you for everything you guys are doing for the industry. Truly appreciate it.
I appreciate
and it's
that.
also
Thank
just
you.
such a chance to learn so much for your viewers.
Yes.
Even people that have been in the industry for a while. So, but I'm excited to tell you about Nitrocross and how Kempower is involved with motorsports, which you might not, maybe you're aware
We've
of.
been talking a little bit
Yeah.
about it, especially when it comes to conversions, and how actually you might think that the hot rod folks wouldn't like going electric, but once you're in something that's electric and you realize the power and performance, it changes your mind.
Well, and in large part, I have to thank Andreas Eriksson, who's back here. He started building these cars from the bottom up. 1,100 horsepower, 51.4 kilowatt hour battery, but we're using our movable chargers. And all the teams in Nitrocross are using the Kempower Moveable Charger, which is a 50 kW charger, right? And so we, if this car rolls off the track and needs a charge, you're going to go from about 20% to 80% in 15 to 30 minutes, depending on where they're racing, right? Environment. But that's it's just been a huge, reliable source for them to charge their cars. There's 20 teams, and they're all using our stuff.
Wow, really
And
interesting.
yeah, and his two sons, Kevin is over here. Kevin's one of the #1 E drivers in the world.
Oh, really?
And him and his brother both race for the team. And so it's just been amazing. If you haven't seen Nitrocross, look it up, because it's just going to blow your mind.
Yeah.
They're jumping these cars 50 to 100 feet across these chasms.
Oh my gosh, I had no idea.
And yeah, absolutely. So, another thing is that the teams in racing are always monitoring everything. And so they're using our software backend, the ChargeEye backend. I don't know if you've gone through. You've actually reviewed it, I think.
Maybe not me.
Kyle
But
might
yeah.
have.
And, I bet he has. And just learned about it along the route.
Yeah, and demos are available. If you need a demo, just get in touch with us, and we'll be able to set one up for you.
Great.
Totally granular, but they can measure everything. They can watch the charging, they can monitor the power,
Of course.
and again, they can use that in their racing as well. And so the final thing that I'll talk about is safety, and safety is paramount for our chargers. Whether you're talking about our movable chargers or our power units and satellites, our all-in-one, you can't have enough safety, right? And the same thing goes for racing, right? You want everybody to be safe out there. So fault detection, automatic shutoff, whatever. You're testing these things repeatedly to make sure they're safe. And so, it's been a real thrill ride, if you will.
For sure.
And so,
how did that partnership come to be?
So it started overseas, and so they were his other company is in Sweden. So they're just south of here, Charlotte area. I'm from Chicago.
I know it's somewhere around here.
but yeah, they so they started racing over there. And Nitrocross is several divisions, but obviously we're interested in the electric cars, right? But that's how it kind of started. And so you take racing, and racing's always instrumental on all sorts of technology, right? But our movable charger, these guys are here. This is Tom, and this is another
good to see you
Eric. You
again.
got two Erics today.
Hello.
And so they can talk more about whether it's one car or an entire fleet. We want to make sure everybody's getting the right solution. And so we will work with our customers to look at their designs or talk about their projects or programs and what they're really trying not only to accomplish today, but what they're trying to accomplish in the future. And so how's it going to grow? Because we all know it's going to grow, right? So you guys want to talk a little bit about the movable?
Of course.
Thank you, Eric.
I've passed the mic.
Thank you.
Well, the Moveable is one of our entry-level products that I think is great in regards to its versatility and in regards to its flexibility. It offers, from a connectivity side, all the North American standards from CHAdeMO to NACS to CCS1. And also, from a flexibility side, as you can see, it's wheeled here, but it also gives the ability to actually mount it. So an environment similar to what you're seeing with the construction equipment, and even similar to what you're seeing here with this rally car, flexibility plays a huge part. These guys are shoveling not only the cars around, but also the movable around on trailers and things of that sort. So we have to have a product that's flexible, reliable, and something that they can depend on whenever they roll it out and they need their charging. So.
Yeah. I love it. I love the not exactly portable but movable solution that is, definitely the definition of flexible. And I mean, I've had a lot of conversations where people are saying, okay, you don't have the grid there yet, or you don't have power there yet. What are the in-between solutions? This is, of course, a fun solution, like a fun aspect, but also practicality. It does seem that is, as long as you have enough power there, you might not be able to have a whole charging setup, but you have some way to get some charge on the ground.
Of course. And one good thing is that this is a great entry-level product. So one thing that we do with customers and potential customers and even OEMs, we have a loaner program. So if you want to understand what type of integration or just to understand this product a bit more, a month, you can pretty much loan it, have it at your facility, do your testing, and see what type of integration is necessary in order for it to perform, say, across the board here.
Yeah, another aspect of it is the serviceability of our charger. It basically shares the same architecture as our larger chargers. So it has a power converter module that you can change, like Tommy was saying in the presentation, maybe around 15 minutes to make the whole change where the charger is up and running again if you need to change it for anything. And a lot of the hardware is also shared between them. The controller is the same, the screen, the contactors, a lot of the components can be swapped easily from the front panel. So that also adds to the charger being like, very reliable and like minimizing the downtime for any of our customers.
Yes, got to have that quick serviceability, and seems like you're carrying through the parts of the design that seems to work so far, and these like pillars to reliability and charging that works throughout all of your offerings. It's pretty consistent.
Exactly.
Yep, absolutely. So yeah, the only thing I'd add to it is that we're adding kind of the cool factor of EV, right? So when you talk about motorsports and Nitrocross, it's the cool. When you watch it again, you're going to be amazed at what these cars can do. And 1,100 horsepower gets you there pretty quick.
Yeah, that's the thing.
And so, but you got to charge up, and so use a Kempower charge.
Practical and fun.
Right?
We need both.
Absolutely.
Thank you all so much.
Yeah, thank you.
Yeah.
Appreciate it.
Continuing on the tour, this might be my last stop. I'm not so sure, but can you introduce yourselves? Who have I found the pleasure of speaking with now?
Yes, how you doing? My name is Chung. This is Sammy. We are part of the service team here in Kempower, North America. This is actually my service manager, senior service manager here. I'm the senior tech, and basically here. Yes, this is the boss.
Yeah.
yes. So we're here to let you know about how our system works with mid-size vehicles. For example, we have here is a Ford Lightning F-150, but also mid-size is more like a Sprinter, like an EV Sprinter van. So same thing, same battery capacity. What I can tell you is how our system work with certain brands and certain vehicles. For example, like an F-150, it depends on the brand, it depends on the battery size, usage. But if it asks for charging when it's plugged up to our system, the most we can provide is 150 kilowatts. Or whatever the car can take in. Yes, take in. But other brand like Chevy's coming out with a new EV. GMC is actually producing a new same platform, so they're coming out. So every time there's a new vehicle that comes out, there's an EV. We always here at Kempower like to either take charge and see how our system work with that type of vehicle. And
interoperability is essential.
That is correct. So
we smoother the kinks before the customers.
Yes, we like to see how everything works before we. Hey, you got a brand new BMW EV charger, use our system to charge.
So does that happen here? You're taking these different EVs into this facility and testing them, or where does that happen?
Like in the main factory in Finland that we have the in Finland, like the German manufacturers that they maybe that we contact them, and then the local importer that here's the car that you wanted to test. But of course now when we get the name in the market that Ford, of course we know it already, but the new cars what is coming, so to see how it works, or if there is something like the maximum power, or we need to change the charging curve, or like the finesse of the car. That so of course 400 volts is here.
Yes.
But GMC 800. And then is it 150 like here? But the EV Hummer 300. And what are the differences? That the software, of course, has its quirks.
Yes.
Even our side or the customer's vehicle, the manufacturer, that if they update something and then something stops working, so then we had, okay, you don't yet have it. Here it works like this, but then the newer one, it works like that. So.
So with the voltage architecture of the EVs, I know there was a question about that before with the Q&A, like is it the same as the chargers that you have over there? But yeah, how are you making sure that you're able to take on this new higher voltage architectures of EVs coming on the market?
Okay, so you want me to answer that?
Your turn.
So hardware, a lot of stuff dealing with hardware. So now you're coming into a bigger market like the North America, where Finland, we had most of Europe. Basically, we provide bigger wires, bigger cables to be able to handle that much amperage, that much current. So North American can be so we can be adapted to American lifestyle, where they need it fast, come and get it, charge it fast, and go. So that's how we do it here.
Okay.
But this 400 and 800 battery voltages that we have maybe on that cabinet, you heard about the adaptive system.
Right.
That basically now we already support the 960 on 500. That then of course there is 25 kilowatts or 50 kilowatts, the allocation of the power modules, but basically it's quite compatible even for now. It's just that of course the protocol or the cable from the satellite to the car, or what is in the ground from the main cabinet to the satellite, so that might be the limitations, but it's more of the customer that of course what they have power, what is coming from the nuclear station or what it is, then what comes to the electrical company when they get the main supply, and then cabinet maybe has something, satellite cable, and then final step of course that the car is telling to us what it wants, and then what we have available.
Because that's significant as well, because not only with NEVI funding do you have to support a range of voltage, but also if you're not able to support that, then you're not able to give certain EVs the entire power that they need. So what is the voltage range exactly that your hardware supports? Up to 960?
960 is basically the 4,000 volts to keep it round up. But 800 volt cars is not that common yet. That of course Kia and Hyundai most likely the best Rivian and these.
Yes.
But if we have the adaptive system, then it's basically everything goes. The 800 is still like a more of the heavier vehicles like the excavators, buses, trucks, and these. That then of course the MCS is totally different, but then you have the different charging plugs. So
yes, exactly. Different standards with that one. Yeah. Okay, anything else about interoperability, medium duty versus light duty versus heavy duty?
No, you're not. No.
In our line of work, we're part of service. So we're service here. So for North America, every time we go out on sites, like we do a lot of trips outside of North Carolina. So for example, I told you about Tennessee. So when we go out to certain sites, we always also see what type of area it is at, what's the traffic going through there, and our system, whatever our customer needs, then we can provide it. Like I said, it all depends on what type of brand it is, what kind of battery capacity the vehicle has, but our system should be able to handle it, whatever they need to juice.
Makes sense.
And like with the trucks and buses, the 800, and hopefully someday the MCS. So it's from our side that basically we just fit the plug and we get what the car wants. So it doesn't matter on what you are charging.
Exactly what you're charging. It's going to work.
Is it boat or truck? So like in Norway, we have the boats with the batteries. So we have experience on those, and who knows is it jet ski or something that they are even with the DC
jet skis, any type of EV equipment. That's what we're using right now to charge.
Yeah, sorry. It's hard to remember.
No problem. So our charger is very universal. You know, very easy to adapt, and we're gonna keep going from there and improving.
Yeah. Great. Yeah, you want to be able to charge anything that is chargeable.
Yes.
So might as well take advantage of it.
Just has the correct plug.
Yeah. Make sure it has the correct plug. And right now in the US, that's CCS, J3400, a little bit of CHAdeMO, but that's kind of fading out. Wouldn't you agree?
That's correct.
Yeah.
And in Europe, that of course,
even in Europe
was the main player with the CHAdeMO, but it's not dying out, but still there is vehicles on the field. But,
it's less being used.
Yeah.
How long?
Yeah.
And the 50 kilowatt charging limit is maybe the Achilles heel in a way.
So we're kind of speaking about interoperability. Adapters are going to come onto the market. How do y'all test those? How does that work? Does it really matter? Or you're just like, well,
we buy them ourselves. We buy a copy of it, either from the main manufacturer of the brand of the vehicle, like Tesla. We'll buy their adapter from a CCS to a NACS cable. And then we also buy off-brand stuff from Amazon and test both and see what's the difference when high temperature, low temperature, at a full charge.
Even the Amazon knockoffs.
The most likely because it's in the field. So
Yeah.
Because if we're able to get it, yeah, because if we can get it, the customers can get it.
Yeah.
So we want to be able to make sure our chargers is able to adapt to their whatever type of adapter they use. Still works on their vehicles.
Interesting. Yeah, I'm sure like we'd rather endorse something that's been tested and tried and true from the automaker, but people will buy third party. Are you seeing any common issues with third parties?
Oh, not at the moment. So our system is pretty good right now.
The more of the
Safety.
Crossing our fingers, yes.
Who knows, of course, what is the manufacturer's the adapter? That of course it's always the money talks. That
Right. Because
cheap ones, bad ones.
and cheap ones that'll get here quicker than waiting for, coming from Ford or Rivian. That's the only ones you should
Like
get
we
it.
notice in North America, it's all about time.
Yeah.
Everybody time is money. People like to get their charge fast, get their stuff here fast, and go.
Yeah, and like with the Ford, that once the NACS compatibility is, for example, with this one, but we haven't yet got the adapter for the NACS to CCS one. But how long it takes for the manufacturer side to get, not rid of, but get the NACS connectors, even these. So, but it's of course the manufacturer side.
Yes.
Issue or problem in a way.
Okay, hello. Do you mind introducing yourself?
Okay, my name is Heather Cook, and I'm a production supervisor here at Kempower.
The first one?
Yep, the first one.
Congrats.
So I'm going to give you an exclusive look at our module line.
Is this the module room?
Yes, the module room. So it's ESD rated. We have the ESD floor. Everybody has to wear lab coats and shoes and all the PPE to cross this line.
Wow, cool.
So that's to protect our components, mainly our circuit boards and our Omega cards, so that static electricity could have an impact on the parts and like deteriorate them. So yeah, having this protective equipment, it just helps our quality.
Of course.
Yeah. So this is our module production line where we make our relays and our control modules. We make a primary and secondary module.
Okay.
For the control modules. And then as you see, we make various relays. That would be a DS4, a DS6, or a DS8. And that's just how many circuit boards are in it, how much power distribution, and how much information does the power unit need to have.
Okay.
So yeah, the relay is like the brains of the power unit, and that it tells which power modules if it needs to switch to another one or use multiple, just depending on what's going on within the power units.
Okay, understood.
Yeah. Yes. So this is actually a highly engineered line. So it's an automated line down the center, but it's people controlled at each of the workstations. So when a module comes down the line, it will come into the work area, and then they will do their part of their assembly process, and the next module will wait for the person to get completed in their workstation and push a button and send it to the next person, and then the next one will come along and then come down into their work area. Okay, so yep, after each workstation, and there's like a quality check. So there's a quality check after each workstation. So I want to emphasize that we have a high amount of quality, and so by the time it gets to the testing, so it will come down to the end, it will come through a whole automated testing software process to make sure it's functioning properly. And usually there's no issue with that it runs through free and clear, and then it's certified, and so there's no like further testing beyond this point before it goes in the power unit. So it's fully tested, cleared, and certified.
And then they continue to test it over there?
No. So these relays and the control modules go directly to the final area from here.
Okay.
And so there's no further testing with these.
So they test the modules over there?
Yes.
Okay,
Yes.
Understood.
So these go directly to final.
These are
and they
good
put
to
them
go
in.
once they leave this room?
Once they leave the room, they're good.
Okay. Very cool.
Okay, and so then I wanted to mention that this is scalable. So if we do pick up a demand, that we can extend these lines, that this is only a small amount compared to what Finland has. If we need to fill this room up, we could, and we could just add on and add on. And then these are designed to be really flexible with changing of technology. So if we have any parts changes or anything, that it's very simplistic or modular design that we can change stuff really easily.
Okay. Great. So this is where the brains are made.
Yes. Yes, the brains. This is where the magic happens.
This is where the magic happens.
Yeah.
Very cool. Has there been any, highlights of working in this? I know that standardizing this kind of manufacturing and production is kind of nascent a little bit because people are continuing to figure out what works best and how to scale up, as well as product demand comes up. Is this exactly how they do it in Finland?
So this is exactly how they do it in Finland, but they actually have separate buildings for each of their products. So this is modules is one building, cabinets is in another, and then satellites is in another. So,
interesting.
But right now we have the ability to flex our people around. So we're still trying to figure out what's working best for us here in the U.S. So we've had every one of our employees train here. They can go to different workstations and just trying to figure out like what works best for us is what we're doing really right now.
Versatile.
Yeah.
Okay, everyone. So that was my walk around of the Kempower North American facility. I really enjoyed it, learned a lot, talked to a lot of cool people, and hopefully we'll see progress from Kempower. I know that most of the questions we get on the Out of Spec podcast is, where can I use this hardware? Where are their sites? They do have a strong footprint, proven footprint in other countries, in other regions in Europe and beyond. And now is their chance to see if they can move into North America and be successful. And we don't have many details about their partners. Those aren't public yet. They have some sites, and one of them is in Tennessee, which is where I reside. So maybe I will be able to go check that out sometime this summer. Otherwise, we're waiting to see how they grow. Let us know what you thought was interesting, curious, and what you want to see from Kempower. Where do you want them to have sites? Of course, they're just selling the hardware, but I think it'll be cool. Interesting to see who they partner with. Either way, hope you enjoyed the tour. If this is your first time seeing me, nice to meet you. We'll see you next time on another video from the Out of Spec Reviews channel. Have a great rest of your day, y'all. Bye-bye.